In this video, we're going to look at how to multiply improper fractions and mixed numbers by fractions. The process is exactly the same as multiplying two pairs of proper fractions. Here's my improper fraction. The numerator is larger than the denominator, indicating that it represents more than 1. And I proceed in exactly the same way as before. Here's my model. I can see I've got 5 quarters going across the bottom here. They've been divided into 6. Here are my 2/6 of the 5 quarters. Okay. So we continue as normal and we multiply our numerators and we multiply our denominators. 5 multiplied by 2 is 10. 4 multiplied by 6 is 24. And as I'm sure you can see, this answer needs to be simplified. The highest common factor of 10 and 24 is 2. So we divide both of those numbers by 2 and we get our final answer of 5/12, which is the product in its simplest terms. What I'd like to show you now, which I haven't shown you before, is a way of making this simpler. We're going to learn to do something called cancelling down. Basically, what that means is we're going to simplify the fractions before we get to the answer. And we do that by looking for numbers which are multiples, which have common factors. So in this question, 2 and 4 are both multiples of 2. So I can cancel these down without affecting the end result. So 2 divided by 2 will be 1 and 4 divided by 2 will be 2. I can only cancel down a number on the top and the bottom. It can be within one fraction, or more usually it happens across the two. You cannot cancel down two denominators or two numerators. It has to be one of each. So I've then ended up with 5 multiplied by 1, which is 5, 2 multiplied by 6, which is 12, and we've got the same answer as before, already in its simplest terms. Let's have a look at another example. So here's the improper fraction, 32 over 5, so quite a lot more than 1 there, and 10 over 8. So actually we've got 2 improper fractions here, and we're going to see how we can cancel these down. The reason for cancelling down is to avoid having big numbers here that we need to sort out afterwards. So the first numbers I notice with a common factor are 5 and 10. Both can be divided by 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. But then also I have 8 and 4. They both have a common factor of 8. 8 divided by 8 is 1. 32 divided by 8 is 4. So my entire calculation has now become 4 over 1 times 2 over 1. Well, 4 times 2 is 8. 1 times 1 is 1. And 8 over 1 is, of course, 8. And there's my answer in its simplest terms. I'm sure you can see how doing 8 divided by 1 is going to be better than doing the 320 divided by 40, which we would have had otherwise. So what about an improper fraction? Basically, we're going to proceed in exactly the same way with one step at the front. We're going to change the mixed number into an improper fraction. So 2 and 3/4 becomes, of course, 11 quarters. If you remember that each of these whole numbers represents 4 quarters, so 2 times 4 is 8. Add the 3/4 we have here, we have 11 quarters. And then we carry on as before. 11 times 1 is 11, 4 times 3 is 12. In this calculation, there are no possibilities to cancel down, so we end up with 11/12. We know this is in the simplest terms because this is a prime number. Next one, 3 1/5 times 3/4. So we're going to start off by making our mixed number into an improper fraction. 3 times 5 is 15, add the 1 is 16. We have 16 fifths multiplied by 3/4. And now we have got some opportunities to cancel down. 4 and 16, of course, have a common factor of 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So then we multiply our numerators. 4 times 3 is 12. 5 times 1 is 5. We have an improper fraction as an answer. To put it in its simplest terms, we must make it into a mixed number. 12 divided by 5 is 2, with 2 fifths remaining.